calculator, instead of 6, yeah, it's going to change it. But something like 3 meters is not going to change.
How do you usually that radius?
Yes, because we're talking about distance from centers. So even though you're right next to Earth's surface, the distance you are from the center of the Earth is 6.37. It's the same as the radius. So any object that is on or close to Earth's surface, we will use the radius of the Earth to approximate its distance.
For not
You can add 3 to it. It's not going to change your answer at all. You would have 6,370,000 and 3 meters, and you would get the same thing once you do that. Go ahead and find what F of G is. What do we get? 7 point. 7.57 newtons. Oh, not right. Everybody? You got what? Yeah, I like that. I was square at the same time. Yeah. Really, it's where you square the whole thing. So G, which is 6.67 times 10 to the negative 11th, right? Times 77. 5.98. Use this E button. Everybody know how that E button works? Use that instead of times 10 to the, it's going to be way easier to type stuff in. Divided by parentheses, don't forget the parentheses. That might be our issue. 6.37 times 10 to the 6th squared. Yeah, 757. It's off by a factor. Double check with your calculator. Make sure you can get 757 newtons. Anything from 2 to 4 6-inch would be fine. So an answer of 760 would be fine. 757 would be fine. 756.9 would be fine. 756.9006504. Now we're in 5. That's not fine. Make sure you include units. That's always going to be worth the point. Don't lose that easy point. Or from the G in the formula, right here. G times M1 times M2 divided by R squared, and then G is equal to that 6.67. Any other questions on getting 757 newtons? So that is the force of gravity acting on George based on the surface of the Earth. With what force does George exert on the Earth? It would be the same. Why? That one law, that's not very descriptive, but you're right. Newton's third law, good. We have forces that react in pairs, or that act in pairs. So if George is accelerating towards the Earth with 757 newtons, the Earth is accelerating towards George with a force of 757 newtons as well. Why then does George fall to the Earth's surface and the Earth does not fall to George? The differences in masses. Go ahead and answer part 2 of this question. And find the acceleration of George. and find the acceleration of the Earth. The Earth does accelerate. The George jumps off the diving board. It does. George was big enough.
Something like we really know it. We think about like sometimes, but we really know if George actually coming back down to Earth or
He's going back down to Earth. Yeah, calculate the acceleration, so it'll be obvious. Defining the acceleration. We haven't defined the second law, but that's what you're using. The second law is technical today. Not worded exactly that way.
are we going to use the combined math?
Do each one individually. Define George's acceleration, we would use George's math. Defining Earth's acceleration, we would use the Earth. What should you be getting for George's acceleration? You should get, acceleration due to gravity here on Earth. You should get about 9.14. Yeah, and it might be off by a little bit, that's okay. We rounded Earth's mass, rounded Earth's radius, the rounded number. Yeah, it might not give us exactly. What's the acceleration of the Earth? 1.27. Okay, so 1.27 times 10 to the negative 22 meters per second squared. The George is accelerating at about 10, and the Earth is accelerating at a rate times 10 to the negative 22 meters per second squared. Who's actually going to move? George is actually going to move. Yeah. Also, the Earth has a lot of other forces acting on it, other than just George. Probably somebody on the other side of the world also jumping off the diving board that counteracts that force and cancels out that very, very, very small acceleration. Moving on, baby. Go ahead and take a look at example 6 in your notes on your handout. There it is. It says 3 masses are placed along a number line. We have a 300 kilogram mass at 2 meters, a 500 kilogram mass at 6 meters, and a 150 kilogram mass at 8 meters. We want the net force acting on the 500 kilogram mass. So at 2 meters, we have a 300 kilogram mass. We have another one out here at 6, and one here at 8. We're looking for the force acting on the 500 kilogram mass, the force acting on that. Yep, exactly like it. The only difference is now we have gravitational force, so we're using the gravitational formula instead of the other. Sounds like you've done one similar to this before. Go ahead, try it. Good answer. Uh-oh. Maybe we should do this one together. All right. Yeah. We're looking for the force on this one, right? Yeah. So there are 2 forces acting on it, right? So we have the force, we'll just call it force 1. Force 1 is a gravitational force. So we are going to use the formula for universal gravitation. Big G. What 2 masses am I going to be using? Not the 2 axes. Good. So the 300 kilograms and the 500 kilograms, right? And what's R? 4. R is 4, but in the formula we are going to. Be careful. This one, our units for distance there are meters. If those at centimeters, it would be 0.0. Right, we need to make sure they get changed to meters. Let's go ahead and find forces 1 and 2. Which two masses am I going to use on force 2 to find force 2? 500 and the 150, yeah. And the distance between them is 2. Find those two numbers. Problem we might run into then, do we add those together? Do we subtract them? Do we do something else with them? I don't know, do we?
Yeah.
Why do we subtract them?
You get one way, one from the other.
Okay, good. So force 1 here would be in the negative x direction, right? We're looking for the force acting on this one. So the force acting on that would be this way, right? So this one is in the negative x direction. This one is in the positive x direction. Both of them have y components of 0, which is good. If they're in the same direction, I can simply add them together, making that one negative. So what would your answer look like then? First of all, what's the number part? Yeah, so 6.26, I think you said, times 10 to the negative 7 newtons. The negative sign indicates what? Is it negative? You're right. I think it should have come out positive. Yeah. Make this one negative, that one positive. Add them together. We should be getting positive. Since it is positive, this indicates the way we drew it is to the right. Does anything up here necessarily mean that that direction is to the right? Towards I would say, yeah, not really towards, I guess it's towards 8. Towards the 1. What would we do if instead they were lined up like this? And we were looking for the force on that one. We would have to do what time? Yeah, this one here would be an X, right? This one here would be a Y. How would I get the magnitude then? You'd have to use the Pythagorean theorem, right? We'd be looking for the magnitude there. Which it would be in that direction. Makes sense. So if you want to do this on whiteboard, you can grab a whiteboard. I have them over here, or you can just do them in your notes. Either one. Anybody want a whiteboard? Okay, yeah, come get one. Come get a whiteboard.